This is gonna be the new 2020 motor. New block, new rods, pistons. Just gonna use the crank that I had in the old engine and the cylinder head, but it's gonna be fully serviced, so it's gonna be almost like a new engine next year again. So I'm using the 20 valve blacktop block as a basis for my builds, and I need to do some prepping on these. So I have drilled a hole for the oil return from the cylinder head and tapped, so there's going to be a return like in some of the 4AGs originally have, but these 20 valve blacktops, they don't have it. Another thing here, I usually tap also the oil line to the cylinder head, so it's just an M8 thread in there, so I'm going to put a little oil restrictor to limit the amount of oil to the cylinder head. And another little modification is to block the original oil line that goes from the pump into the filter housing. So I'll have tapped, there's threads in here so I can plug these, because with the dry sump I'm not going to need the oil supply through the original pump. Pump is going to be, the pump housing is in the front just to hold basically the main seal, the crank seal, but the pump is not used for actual oil pressure buildup or anything. Yeah, so the big topic with this block was when I took it to the machine shop, they had to really, I wanted to get the main bearing line properly done for the girdle, and the girdle didn't really sit that well on the main caps. There was quite a big difference between the basically the girdle was warped, so we had to grind first the girdle to be straight, and then we machined the caps and also the block here, so that all the main caps were in the same height, and now it sits flush with the girdle with the sides of the block, and it's a fresh main line as you see. So what I need to check is if basically the size of the main bearing line is where it should be. I usually want to have it on the tight side for the bearing crush, so now I need to check what the actual size is, if it's where I basically gave the spec to machine it. So I'll put the bearings in, tighten up and make a measurement, and then check that it's gonna give me the main bearing clearance that I want. So that's the next step. Okay, so these are the bearings. I'm using pretty standard stuff, these ACL bearings. They're fairly good. I haven't really had any problems with these. So these are just the standard ones for the 4AGE. However, like you saw already earlier in the old bearings, I use coating on these. So when I was still in the US, there was a local shop in Michigan that coated my bearings, and now that I'm here in Germany, I found a local company here. I shouldn't maybe say a shop, because it's a pretty well-known big company, and they do coat bearings and stuff. And this is now something which is supposed to be the best coating in the world for bearings, so we'll see how it works. Okay, so I cleaned up the bearings. One thing I really have to say, this coating, whatever now it is, it's much more slippier to your finger. Like, it's definitely, the color is more lighter gray than the one made in the US was a dark coating, but this is now, it's very slippery. When you have a little bit of oil in the paper, it's or not even oil, it feels really slippy. Okay, bearings are in there. Here is the girdle. You see how the girdle is machined, or it's actually grind on a magnetic table, and that procedure was not very easy to get it completely flat. So I'm gonna tighten this up and check, then I can measure. I have some very professional measurement equipment to to check the clearance. That's why I had to put the old block back together. I wanted to make a measurement with those old bearings in the old block, if it was still close to what I measured for the clearance to be when I put it together. So I calibrated my fingers and my machine, or my measurement equipment, but you will see it shortly. One thing here, I'm using the rear-wheel drive 4AGE oil pan. So I got a cast aluminum dry sump pan, and since this is the blacktop block, some of the holes are in a different location and so on. So I've made some modifications here to be able to mount the rear-wheel drive style oil pan into the blacktop block with the girdle. Looking good? Okay, so I've got my cheap Chinese bore gouge, and I've set my cheap Chinese micrometer for the reference size of 47.98, and next thing, oops, impossible to hold the camera and get it straight there, but anyway, I set it for the reference 0, and now what I'm gonna do, the main bearing line is torqued up, bearings are in there. I'm just gonna check what my rate here is, and that's gonna be my bearing clearance. Quite easy. Okay, so I've got the new block with the old bearings. Just wanted to measure the clearance with the old bearings on the new block, and it seems that the tolerance on the main bearing line is a little tighter than it used to be. I see a couple of hundreds tighter clearance now, and it's maybe a bit too tight. So I gotta put the old one back together without the bearings, and I'm actually gonna measure what the main tunnel diameter is at the moment, and then measure it on the new one and decide what to do. So there's my TDC. Going to check how much the piston comes over the deck, just to see if I still need to machine the block. So the height is in the original, the block height is original at the moment. It's just cleaned. Checking here, how much does the piston come over the deck? It seems that it's a little under 500s at the moment. So I've got two options for the, or actually there's maybe 3-4 options for the cylinder head gasket, and I need to figure out which one I'm gonna use and if I'm still gonna machine the block or not. Okay, so since the pistons come around 3/400s over the deck, I'm gonna use the 0.8mm thick TRD gasket on this. And actually the cylinder number 1 is maybe 100 higher than number 4, so the 4 runs hotter, and I would say it's not really a problem. It's that way, it's definitely the best. But this is once tightened gasket here in the picture. I just need to order a new one, but I'm gonna put it with the TRD gasket this time. Okay, so this is a really hard decision here. I already decided not to machine from the block, but still I ran through some calculations for the compression ratio, and actually 500s makes, let's say, a noticeable difference in the compression ratio. So I'm gonna take the block anyway in the machine shop and clean the deck surface and get squeeze everything that I can out of the this engine to get the compression ratio as high as I can. Okay, so I got the cylinder block back today from the machine shop. So last time I was checking the main bearing clearances for the crankshaft main bearings, and also checking the deck height for the new piston rod combo, and decided to take the block still once more to the machine shop. So we actually shaved 500s of the deck, and then we adjusted the main tunnel size a little bit just to get it where I wanted. So basically how I usually do this stuff, I spec what I want to have as clearances and what kind of tolerances and so on, and then I do trust the machine shop to do what I ask them to do, but still I want to repeat and measure also myself. And now what I did for the old cylinder block, I actually also measured everything from the old block to make sure that how much there was wear on the cylinders, what kind of where the clearances changed from what I set them to, and so on. So I do have some equipment myself that I can do that. It's not necessarily as good quality as in the machine shop, so of course I try to see if I can repeat the same what they do in the machine shop. So okay, so I checked the cylinder clearances where they were in the old block with the old pistons, and there was actually quite a bit of wear on the cylinders. I wasn't expecting to see that much, but basically the clearance has come up. It's not really the bore size itself, but the piston. And I already mentioned about this earlier, the coating on the piston skirt has completely worn off, and also, even though it doesn't look like there's wear, I think the surface has definitely, there's
maybe 300s missing from the skirt, and as the piston is so, the skirt is so is not very high. It's basically the point where you can measure the piston diameter is basically here on the edge of the skirt, and this can easily wear out a couple of 200-300s, and now it's definitely then on the bore size. The clearance is way bigger than where it was originally set. The new bore is maybe 100 tighter than what I can measure from the old. However, in the old bore, the wear is not so clear. It's still, there's no taper. The bore size on the top of the bore and down where the piston, basically where there is no wear, where I can get a reference measurement where it was originally, it's still pretty much the same. So I can't really measure much taper or any other. It's round. There is no problems. The size is the same in both directions. So yeah, I think the piston wear is where the clearance has come up. So now with the new one, with the new piston having the coating on the skirt and so on, we were speaking about it with the machine shop, how much actually the coating is, how thick it is, how we will take it into account. So we decided, even though the nominal piston diameter is now the same, we ended up going 100 tighter on the bore size. And now what I can measure is basically as a clearance is to the spec what we decided with Wiseco is good. I write down everything. I got my black book here, so it's nice to track down then again next time when this engine is or has been run, and then when I'm taking it apart next time, I can check how well I can repeat the measurements and how much there will be wear one day. So the crankshaft is in place, but I'm not convinced yet that I'm gonna put it together. So with the main tunnel size, I wanted it to be on the minimum spec for this 4AGE blacktop block. It's 52.02 is the minimum size that Toyota defines for this. We went a little tighter, and now what I see with my clearance is I'm basically now with the same kind of a bearing thickness. I'm a little tighter, of course, on the clearance, and the crank won't spin so well. I definitely see now that the clearance is going into the point that even the crank is dead straight. We checked, we actually also polished, of course, the journals. There was those little scratches, so now it looks really nice. But anyway, the crank won't spin when I tighten this up as freely as I want. But okay, the clearance is it's very small now. I'm not gonna tell you what the clearance is, but I've never run this small main bearing clearance before, so I wanna be 100% sure there's not gonna be problems. So I'm gonna change a few bearings to the bigger tolerance. So luckily ACL makes the bearing with two variants, and I can use the one which gives me maybe 100 more. And I'm not gonna put it in all the main journals, but two of them I'm gonna use a bigger clearance. And then I know already, because I checked with these bearings, it spins freely. But since we slightly changed the tunnel size, I was hoping that would be enough, and then I would basically run the same bearing on all the main caps, but that just didn't work out. So it's back and forward, is measuring here and there things, and sometimes quite frustrating. I was hoping to actually put this already together today, but I still need to get some bearings coated. Those bigger tolerance bearings, they're not coated. So it's gonna be another little delay to get this back together. But anyway, I can still. Next thing I'm gonna do is I'm gonna move into the piston rings. I'm gonna check and set the ring gaps and prepare the piston rod assemblies, put them together, make sure all is good. So then next time, hopefully when I will have the bearings, I will change a few bearings on the crank and then finally put it together. So it's all cleaned up, it's all washed. It still went once to the proper washing machine in the machine shop, and now it's getting close.